Today I'll demonstrate the ability of the CAD board to configure itself from the serial flashes on the board. Before I show that, I need to demonstrate that the board actually isn't configured right now. What I'll do is I'll switch the board over so that it is powered from this 5-volt jack, and then I'll plug a 5-volt power supply into it. And as you can see, the board does nothing. Press the reset, you see no activity on any of the buttons, so it's not the FPGA isn't programmed. And now I'm going to put a bitstream into the serial flash, and then we can see that the board will run when it's in this standalone mode. So let's do that. Going to switch it over so that the board is powered by the Raspberry Pi, and then I'll attach it to the Raspberry Pi, and I'm going to slide this little piece of cardboard in between there because I don't have the little supports on there, just to make sure that there's no touching of this board to the Raspberry Pi and an explosive short out. Then I'm going to attach the Raspberry Pi power. The power supply isn't currently plugged in, and I'll plug in the power supply. And the Raspberry Pi starts to initiate. Now I can open up PuTTY, and that will allow me to connect to the Raspberry Pi from my PC as soon as the Raspberry Pi has finished its boot up sequence. Okay, let's give it a try. It's always hard to tell how long it's going to take. There we go. Okay, now go to the directory where I keep my bitstreams at. And I have a program called SPI Flash. And let's see what the options are here. Okay, I want to program a bitstream into that, so I'll use the -P option. And I'm going to program it with the SDRAM test program. That's SDRAM test bitmap.bin, and we can program that into the serial flash. So you can see the progress. SPI Flash is written in Python, so it's not blistering speed. It does about 25 kilobits per second programming speed into the flash. So it takes about 40 seconds to get the bitstream all the way programmed in there. While we wait, perhaps I can sing a song. Well, maybe not. And the bitstream has been programmed in the serial flash, and you can see over here on the CAD board that the 4 LEDs have come back on. That shows the program that was in the flash actually got loaded into the FPGA. You can see that it's actually running. But that's no proof that the serial flash actually did that, because possibly the Raspberry Pi just wrote it into the FPGA and didn't even use the serial flash, because I might trick you like that. So what we're going to do is we're going to power down the Raspberry Pi and then disconnect the board, and then show that it can run even when the Raspberry Pi is not there. So we'll shut down the Raspberry Pi. And it'll take a couple of seconds to let the Raspberry Pi finish its power down sequence. And I'll say it's done. Try to unplug the right power supply. And then this is always hard to get off. Okay, now I'll switch it back to where it's powered by the 5-volt power jack, and I'll plug in the power jack to the board, to the cat board. And you can see that the 4 LEDs have come on, showing that it's passed the SDRAM test. So let's reset the FPGA again and watch that. Do it again. It also responds to this button over here, and it's passing the SDRAM test each time, which shows that the bitstream in the serial flash has been written into the FPGA, and it is executing that without the Raspberry Pi connected, as you can see. And that's really all I wanted to demonstrate at this point. Thanks for watching.